Okay, everyone. So, welcome to week 8. Now we are in week 8 lecture. So, week 8, right? So, how fast we are moving, isn't it? So, for basically 5 more weeks to go, right? That's right. So, we will go through some of the now our main focus from this week on now last couple of weeks onwards. Actually, we are now focusing more on design aspect of databases, right? So entity relationship diagrams. So this week also we are trying to capture some more important aspects regarding design part of databases, right? So today we are learning some more information regarding the designs and one thing that you need to remember is when you actually learn these things you may actually you will see kind of some patterns exist in some scenarios, okay? Some very similar patterns, right? It doesn't matter which scenario you are dealing with, so the patterns will exist in most of the scenarios. So if you know these patterns, you can eventually apply this pattern to any new scenarios that you will encounter, right? So that is a trick. That is the best part of interrelationship diagram, right? All right, so let's move on to today's lecture. Um, Now, first, before I move into anything else, so I want to actually remind you one important thing. So now, so in this unit, we are providing you the narrative, right? So we'll give you a business narrative, and then we need to design ERDs based on the narrative that given, right? Now remember, when you have a narrative, please make sure you use the only information or the only the attribute that given in that narrative to design your ERDs or entities. So don't bring any new business rules or any other new information or new attributes to design your ERDs. Okay, so do not invent any identifiers, right? So sometimes now when you go to actually industry, probably sometimes we will invent our own identifiers. Doesn't matter whether they have the unique ID, but we can invent our own identifier. We call it as surrogate keys. So, but in this semester, in this unit, we don't do that, right? So we are live with whatever the information given to us, and we need to design the identifiers based on the information provided to us. Okay, so don't invent any primary keys if it is not mentioned in the business narrative or the narrative that we have given. Okay, so that is something that you need to remember. For example, if the narrative says the customers, right, have first names and the surnames, right, don't invent any key or any primary key such as a customer number if it is not mentioned, right? So in this case, the best primary key that we can assume is a combination of probably first name and the surname, right? If they mention the customer name as first name and surname, we can to combine these two to make a perfect identifier or perfect primary key, right? Right, now remember that, because in the tests that we are going to do in week 12, so you will get some scenarios, so make sure that you use the information provided in the case study, right? And sometimes, for example, if a scenario says something like this, if it says there are some meetings going to held between certain employees, right, and then the meetings are going to held in many times per week, right, then we can make a reasonable assumption that the meeting is going to held in a specific date and a specific time, because it actually tells you, or we can make an assumption, right? Meeting will going to held in a specific date and the time, right? And then we can take the date and the time as a primary key of the meeting entity, right? But if they have included some other information like a room number or any room location or any location, then you can take that as a part of the identifier as well. right? If the room number is not provided, make sure that you are not going to invent any room numbers. Okay, so you need to live with the date and the time, right? So these are the small bits and pieces I like to actually remind before we move in, because this semester we are not going to invent any surrogate keys, right? Surrogate keys are the new keys we invented by the designer. So we don't do that in this semester, right? But if you actually, it's a very good thing to do, because when you go to the industry, you need to invent new keys sometimes. Okay, but in this semester, because we are trying to live with the business rules as is, because then of course it reflects, because if you use the attribute reflected on the business rule, and even though the attribute or the identifiers probably very lengthy, because sometimes you need to combine 3 or 4 or even 5 columns to make it as a composite identifier, to identify uniquely a specific row. You need to have 5 columns to combine. We can't help, right? Because it's actually good thing to do, because when we implement or when we actually discuss the business rules with the users, if you use the scenario attributes, it makes sense for the people or the users, right? Because they can understand basically. Okay, for example, if the meeting held in a specific date, specific time, you can say, okay, it looks like a unique identifier, the date and the time for a specific, because you can have only one thing can be happen in the same date and the same time. So then the users can identify it as well, right? Non-technical people. But if you invent something new key, probably it will not make any sense, right? For example, meeting ID 001. What do you mean by that? Meeting ID 002. What do you mean by that, right? So there is no kind of a meaning associated with those invented keys, right? So something that you need to remember. Okay. Right now, I am going through a few case studies, or very small case studies. Now, why I'm actually talking these case studies, because each of these case studies have its unique something that you can learn in, or unique patterns, I would say, and then you can actually learn these things, because because these small bit and pieces you can apply to another scenario, scenario in the same way, right? So let's go through the case study number 1. Now it says there are some appointments are made between the doctors and the patient. You know, the patients and doctor, right? So clinic, right? The clinic, we have doctors and the patient. So the appointments are going to be made between the doctors and the patient. And it says each appointment is held at a specific date and a specific time, right? A fee is charged, and the patients have an IDs and names, and the doctors have the names, right? So these are the only information provided to us. Okay, so how are we going to design an entity relationship diagram? So very easy. What we can do is we can go through the 9 steps, and then first we can identify the strong entities. So when you read this narrative, you may have realized there are 2 strong entities, right? One is the doctor, one is the patients, right? So doctors can have many appointments with the patients, and patient can have many appointments with the doctor. That is what it implies in this narrative. Okay, and it also says patients have an IDs and the names, and doctors have their names. Now here they haven't mentioned any ID for the doctors, right? So it just mentioned doctor names, right? So that means we can assume names mean first name and the last name, right? So it's obvious we can assume, make an assumption like that, right? So what I do is I take the doctor's first name and doctor's surname as 2 attributes, and it make as a composite identifier for the doctor entity, right? And then when it goes to the patients, but if they have mentioned patients have an IDs and the names, right? So these are the 2 attributes. So that means obviously I can take patient ID as a primary key of the patient, right? And then it says the patients and the doctors are making appointments, so they have an appointments in a specific date and a specific time, right? So that means when we expanded this many-to-many relationship, obviously we have a weak entity here, right? So the date and the time actually belongs to that weak entity, right? And then it says the fee is going to charge for a specific that particular meeting, right, or particular appointment. So the fee attribute actually comes in here, right? It's not going to attach into the doctor or not going to attach into the patient, but it comes here, right? So the next question is how we going to determine now the appointment, how actually normally the appointments are made. When the appointments are made, because the doctors, when they come to work, then they say, okay, I'll work 5 days, so I may have certain number of appointments per day. Okay, say for example 6 appointments or 8 appointments per day, right? So 8 into 5 days, so that means 40 appointments I can handle per week, right? So what is the identifier for the appointment in that case? So that means I need to take the doctor's identifier, right? So in this case, doctor's first name and the surname, right? And then I need to combine it with the date and the time to make an identifier for the appointment, right? But I'm not going to take patient ID, right? Patient ID. Why? Because when we make an appointment, right? For example, if a doctor says, oh, I can make 40 appointments per week, I don't know who is the patient need at that time. Simply, patient may have not called or make an appointment, right, with the clinic. So that means I can't take the patient ID as part of the identifier, right? Understand? So that's a bit of a tricky thing to handle. So we are taking only doctor's identifier or doctor's primary key as a part of the identifier for the appointment. So that means there is only one underline in my right hand side, but there is no underline in the left hand side, no underline in the right hand side. Okay. So the appointment, the identifier or the primary keys, doctor's first name, doctor's surname, plus the date and the time, right? So date and time comes from the appointment itself. So this is a composite identifier. Okay. So it actually makes sense, right? Rather than having a appointment number or something, it makes sense if you read this. You can understand, anybody can understand the primary key of this appointment entity. Okay, but remember we had two foreign keys, right? So the doctor's first name and doctor's surname is a foreign key as well as patient ID. All right. So what are the key points in here? As I mentioned before, appointment is a weak entity because we need to expand now the many-to-many relationship with definitely there's a weak entity called appointment. It's a weak entity. In order to make a primary key for the appointment, we need to borrow an attributes from other entities. So we just borrow the attribute from the doctor's entity in this case. Because we don't know the patients who was a patient at the time we make the appointment, right? So the primary key of the appointment, it ensures that doctors are not going to make 2 appointments at the same date, same time. So that is what we mean by that. That is why we take doctor's identifier for the appointment to make sure that no one doctor make 2 appointments at the same date and the same time, right? But then we have a question. The question is, how can we make sure that patients are not making a double booking at the same date, same time as well? Because we are not taking the patient ID as a part of the identifier. It actually just comes here as a foreign key, right? So how do we make sure that one patient is not making double booking with the same date, same time, same date and the same time, right? So there are so many ways that we can handle that scenario. So one way of doing that is we can actually create a unique constraint in our appointment table. Now remember the unique constraints, right? Remember the unique constraint, check constraint that I have discussed, I think around week 5 or week 4, week 5, I guess, yeah. So we can have a unique constraint. So how can we create a unique constraint? Remember, when you create the tables, we can implement the unique constraint. So in this case, I can implement a unique constraint when you create the appointment table, right? So in the create table statement, I can have a unique constraint, right? By combining the patient ID, date, and the time, these three together make it as a unique, right? So that particular row is unique, right? So that means if the patient try to book another appointment at the same date at the same time, we will get a error message saying the unique constraint has been violated, right? So that is how we can implement that problem or that issue, or we overcome that particular problem, right? Uh, but in the ERD, it actually not showing that. But when you implement, you need to implement that constraint. Okay, so that is a limitation of ERD. Certain things we can show, certain things we can't show, right? Okay, did you understand that problem, right? Did you understand, everybody, this case study, small case study, and the issue associated in this case study? Yes. Shana, not really. You don't. So others, yeah. Do you need to re-explain this scenario again? Others, do you need the re-explanation? Can you? Yes. Okay. So what is happening here is, now you remember. I'll go back to this. We have a scenario. Doctors are making appointment with the patients, right? So it says the doctors have their own IDs and the names, and patient have doctors have their names and the patients have their IDs and the names. So the first thing first. So first thing is we design the strong entities, right? So we have two strong entities. Uh, Two strong entities. So doctors and the patients. Yeah, that's clear, right? So doctors and the patient. So you know how to define the primary keys of the doctor, right? Because it says doctors have the names. So in this case, we need to assume name means you can have first name and a surname. So therefore, what I have done here, I made an assumption. Okay, so doctor's first name, doctor's surname, right? And these two make a primary key for the doctor, right? So it's obviously a strong entity. But for the patient, they already given two attributes: patient IDs and the patient names. Yeah. So I can assume patient ID is unique, so that's the primary key of the patient. Okay, and then it says the appointments are made between the doctors and the patient. So that means we need to assume one doctor can have multiple appointments, and similarly, one patient can have multiple appointments with the doctor. So there is a many-to-many relationship between these two entities, right? So that is how these two interaction happens, right? So many-to-many means we need to create a weak entity. So that weak entity in this case is the appointment, right? Appointment. So appointment, it says, it actually what it implies here is who is the doctor, who is the patient, and what date at what time these appointments are going to happen, and what is the fee the appointment going to charge, right? So the fee, obviously, fee information comes with the appointment. Okay, so these are the three attributes that we can see from this scenario comes into the appointment weak entity. And then the next step is we need to determine what is the primary key of the appointment, right? That is what we need to know. So we know there is a date and the time. So if you take the date and the time, it's kind of like a primary key. But again, we need to know who is the doctor in that particular date and the time, because we need to make sure that doctors don't make two appointments at the same date and the same time, right? But then the other issue is when the doctors make an appointment, right? Doctors made an appointment, say for example, for 5 appointment or 6 appointment per day, they don't need to they don't know who is the patient coming into their appointment, right? Because patients can actually ring for the appointment from some certain days, right? Okay, so that means we are not in a position to take patient ID as a part of the identifier for the appointment. So what we can do is we can take the doctor's identifier or the doctor's primary key as part of the identifier for the appointment. So doctor's first name and the surname plus date and time make a kind of a perfect identifier. So we know who is the doctor is, which date, which time the appointment is going to happen. But we don't know still who is the patient is, right? If the patient are not making booking, right? So that is okay. That is okay. Okay. So we can have a null value because we can have a series of appointments created first. We can have null value for the patient ID. Okay, because it's because we don't know. So if the patient comes in, then we can have we can put the when the patient rings, for example, then we can actually update the appointment table the relevant patient ID in the in that particular foreign key column, right? Foreign key column. Okay. So that is what actually I have talked here. Okay. But then there is another issue because how can you make sure because the patient can call and ask, okay, I need an appointment at 11:30 today, right? And then he can call again in another time and say, okay, I need to have another appointment at 11:30. So how can you make sure that the patient is not going to book the same date, same time, right? With the two doctors, obviously. Okay. So we can't implement that in a ERD way because there is no, because if you can't take the patient ID as a part of the primary, yes, obviously the reason is we don't know who is the patient when you make the appointments for the doctors for a given week. So that means we need to actually move into some other method to overcome that issue, right? So the other method that we have is, one of the method that we have is we can create a unique constraint in the appointment table, right? Now remember the unique constraint. What do you mean by the unique constraint? If you create a unique constraint in a entity, what do you mean by that? That means a certain columns that we put as a unique can have a unique value, so you can't repeat the same value again, and it looks like you are implementing another primary key. Okay, apart from the original primary, it looks like that, right? So that is how we can overcome that patients are not making double booking at the same time, same date, same time. Okay. So we can have a unique constraint saying, okay, there is no repeating patient IDs, date, and the time in the same table. No duplicate values. Okay, understood? Did you understand that? Right. So we'll go to another case study, and then you can see the same pattern will repeats in the other case study. So Shenal, you have question primary key does the same thing. Yes. So primary key does the same thing. Yes, that's right. Yes, because sometimes we can't take every column as a primary key, right? But sometimes we need to make sure that some columns are unique, right? We don't want any repeating values comes in certain columns. So how can you make sure that we don't have any repeating values? You can use the unique constraint, right? Unique constraint. Okay. Right. So think about this. This is a kind of a small scenario, but there are something that you can learn, right? So there are things that we can implement using ERDs. There are things that we can't implement using ERDs. So we need to go back to our create table statements and then do something to adjust something to make sure that the business rules are adhering to, right? Because in ERDs we are showing the business rule, yeah. The main reason why we create ERDs is to implement to show the business rules, how we're going to implement in the database, right? There are certain business rules we can show in ERDs, but there are certain business rules we can't implement or we can't show in the ERDs. We can actually show it by implementing, right? So Shenal, you says in this case, even without the unique constraint, primary key will do its job. Primary key will do its job, but there is a problem. So what will how you going to make sure the patient is not booking the same date, same time twice? That is a problem, right? Yes, it's a unique. Yes, at the same, in this way we can have a unique customer, but there is no problem. But there is a business rule. No patient can book twice at the same date, same time, right? Actually, it's obviously not practical as well, right? If a patient can you book twice I mean same time, so two doctors? No, right? It's not practical, right? But how can you implement that? Right? Implement that by using a unique constraint. Yeah. Did you get it, Chanel? Yeah, that's the problem. Yeah, practically we can't. I mean, programmatically, yes, it's correct. Yes, programmatically, Chanel, it's correct. Yeah, it's unique, right? Because date 10 time plus doctors identify. Yeah, it's correct. But practically, it's not right because two patients can have twice the appointment the same date, same time, right? Actually, you can't allow it, right? You can't allow it. So that is why we need to go back to our create table statements and just do a bit of an adjustment there, right? So these are the bits and pieces you need to think about, right? When you design a ERDs, right? Right, now we are coming to the second case study. Now this case study is little different to the earlier one, but there are some similarities as well. Now let's go through this case study. Here it says there is an investment company. Now they supply some advice to the client. Now think about a bank, right? So they are giving kind of an investment advices to their clients. So clients make bookings with one advice at a time, right? That's what we mean by that, right? Clients make bookings on a one advice. So advisors and clients have names and the phone numbers, right? And each meeting is booked into a seminar room at a specific time and a specific date, right? Now here in this case, we have a advisors, clients, and they are making they make a meeting. It's like early appointment. Now this time I'm calling it as a meeting between advisors and the clients, right? So here now here in this case three strong entities because why now here I made an assumption advisors and the client name as primary keys. Actually you can underline the phone number, it's okay. So here but I'm also make an assumption like that. But the important thing is the meetings, right? There is a meeting between the advisors and the client. And what is the primary key for the meeting? But it says each meeting is booked into a specific room or specific seminar at a specific time at a specific date, right? Date, time, room in combine make a perfect identifier, isn't it? So that means the entity in the middle in this scenario is not a weak entity, it's actually a strong entity because it has its own identity. We don't need to borrow anything from other entities. So this entity is very strong, can stand by itself, right? It can stand by itself. That is what we mean by strong entity, okay? Because it has its unique identifier, okay? But we still have foreign keys coming from other entities, right? Because we need to know who is the advisor in the specific meeting and who is the client involved in that specific meeting as well. So that is why we have the foreign keys, right? Right, then we have the same issue, right? We have the same issue. What is the same issue? Now, even though technically it's quite correct, because this is a perfect identifier. That's right? So there is no violation of primary keys. But practical sense, sometimes, how can you make sure that investment advisors don't have double booking at the same date, same time, as well as the clients doesn't have double booking at the same date, same time, right? So say the same problem as before, isn't it? So the same problem as before here, appointment, right? How can you make sure the patients are not double booking? We need to have unique constraint. But in this case, how can you make sure the doctors are not double booking? Because we already implemented double booking issue by taking the identifier from the doctors to this side, right? So it actually shown in the ERD, but the patient double booking is not cannot be implemented here because I explained that because when we make an appointment, we don't know who is the patient, and so we can't take the patient ID here, right? So therefore, we need to implement using a unique constraint. So in this case, um, in this case, we can have we can actually take. We don't need to actually take client number and advisor name to make a identifier here, because we have already date and the time room being combined, make a perfect identifier. So this will obviously a strong entry. We don't need to borrow this. So if you don't borrow this from other side, then we have issue saying, okay, how do we know make sure advisors and the clients are not double booking at the same time? So what we can do is we can actually do the same same thing like what we did earlier, but in this time we can have two unique constraints, right? Two unique constraints. So one unique constraint is combining the advisor name and the date time, and second unique constraint is by combining the client name and the date and the time. So when you create the meeting entity, I can have two unique constraints in the meeting entity, right? One for the advisor, one for the client, right? So date, time, advisor name, one constraint, date, time, client name, the second unique constraint, right? So that means if I try to insert the same client, same date, same time, I get an error message saying unique constraint violated, right? So that obviously we actually overcome that problem, that practical problem, okay? So does it make sense, the earlier one and this one, the doctor scenario and this problem? Because it's exactly the same, but it quite different because of it now become a strong, right? So that means we need to have an additional unique constraint implemented in our the meeting entity in this case, right? So you can see a kind of a pattern is same, right? Pattern looks same, around 80% it's same. The only difference is there is no weak entity, but we have strong. Okay, right? Is it clear, guys? This one, this scenario, case study 2. Yes or no? Can you give me? Yeah. So Chanel, okay. How about others? Molly, Kunja, Liam, Sia. Because I want everybody in the same page. Okay, because we are now going to a little bit different territory, right? So I don't want anybody left behind. Yeah, Liam is okay. Yeah, good. Sia, good. How about Sue? Shangmin, you guys okay? Kunjal, I guess it should be okay. Yeah, Kunjal. Can you just reply to me so I know exactly? Yeah, for now, okay. All right. So shall we jump to the third one now? Okay, third case study. Now this is the third case study. Same, right? Same scenario, same like scenario, but again, obviously there's something that we can learn, right? Let's read this now. Case study 3. Right, so here in this case, the university scenario, so we have tutors, right? So it says tutors in INF10004 database project. So this is a project-based unit. Arrange meetings with the students to discuss some issues, right? Each meeting has a unique meeting number. Now they are giving a unique meeting number, right? So there are meeting between the tutors and the students. But each meeting has a unique meeting number. The meetings are held at the tutor's office at a specific date and specific time. Each tutor has a tutor ID and name, and the student have their IDs and the names as well. Right, so they have tutors, right? Tutors have IDs and the names, right? Tutor ID is the primary key, so it's obvious. And then we have the students. Students have the ID and the student name. So student ID is the primary key. So obviously tutor and the student are primary. Looks like a strong entities, right? So then they have a relationship between tutors and the students, right? What is relationship meeting, right? They are having many meetings between them, right? So obviously that means we have another entity comes into play. So that entity is the meeting, right? So we need to now think about what kind of entity is the meeting is, because they says each meeting has a unique ID, right? So meeting ID, so that means obviously the meeting is now become a strong entity, because each meeting ID is a unique, even though they have given the date and the time, right? They have a unique meeting ID. So in this case, it's quite different. Why it is a strong entity? Because they have given a meeting ID or meeting number, right? It's quite different to here, right? Here, why this meeting is a strong entity earlier case, because they have given date, time, and the room number. Because in any given date, any given time, any given location, we can have only one meeting, right? We can't have two meetings, right? So, but in this case, since they have given the meeting number that's unique, so obviously meeting is a strong entity, right? So, so this is how the model looks like. So no underlines. But the meeting has two foreign keys attached to it. Okay. So the same issue comes in again. So how can you make sure that the tutors and the students are not double booking at the same date and the same time, even though there is a unique meeting number? How can you make sure they don't double book? So what we can do is we can have two unique constraints implemented in our meeting entity, right? One for the tutor and one for. So how to make a unique constraint for the tutor? I can have where I can say, okay, unique constraint, give the constraint name, right? Unique, and then open brackets. I can put tutor ID, comma, date, comma, time, right? Date, comma, time. So that's 3 columns in combine. And then I can have another row saying constraint name, unique, open the brackets, and I can say, okay, student ID, date, comma, time, unique, right? So 2 unique constraints. You know how to implement the unique constraint. Remember, just go through the week 5 lecture, you will know how to implement. Remember the constraint, there are a bunch of constraints I have done, right? Unique constraint, check constraint, not null constraints, right? How to name the constraints, remember? So if you go through that lecture, you will realize how to implement these unique constraint in your meeting entity. Okay, but we can't show that in ERDs. So that is something that you need to remember. Okay. But there are obviously some other complicated issues. So how can we actually make sure, for example, if you go back to our doctor-patient issue, because sometimes we know that we can't we can't have double appointments. We can have implemented it using your unique so where is this unique constraints, right? But how can you make sure that there is no overlapping between the time and the date, right? How can you make sure that, for example, one meeting or one appointment can start at 8:59 and ended up at 9:15, right? With the appointment with the Fred, that's the patient. So how can you make sure there is no other appointment starting between these two? For example, if there is another meeting start at 9:07 and ends at 9:28 with the patient, so how can you actually make sure? Because obviously, if you have these sort of scenarios, obviously it will pass through this, because each of these two entries are unique, right? So it obviously passed through that. Okay. Now the problem is these kind of complicated things cannot be handled using ERD means or by implementing unique constraints itself. There are some other issues as well. For example, sometimes if you have a scenario saying, okay, you have appointments with the patients and the doctors, each patient or each appointment, a doctor cannot prescribe more than 4 drugs per patient per appointment. How can you make sure you implement that kind of business rule in your database, right? Or maybe if we given kind of, for example, payment plan for a particular patient, how can you make sure that all the payments that we are received for a particular patient invoice not exceed the total invoice value, right? So you can see there are obviously some other complex issues that we need to actually deal with when you deal with the databases, right? But the problem is we can't deal these things using ERDs. We can't implement in ERDs, or we can't show that in ERDs, or even we can't show that, or we can implement it using unique or other constraints in the table. So how can we deal that? Unfortunately, we need to now take some other path, right? So there's one path that we can take, is we can actually go on programming languages in SQL. So each SQL server, so each database management systems has its unique programming languages, right? For example, in Oracle, we call PLSQL, Programming Language SQL, right? Likewise, some other database management system like Microsoft version of database management system, they call it MS SQL Server. They have a SQL language called TSQL. Now, what do you mean by the programming language? Remember, the programming languages, we can write some codes, we can pass some parameters, right? We can have if statement, loops, etc., etc. We can create some functions, we can create some procedures, right? Okay, so we obviously need these kind of things to handle those sort of specific scenarios that just I have explained. Okay, so in SQL, in PLSQL, or the Oracle version, Oracle what do you call Oracle database management systems, if you use PLSQL, or programming language of SQL, so we can write as a stored procedure. There's a thing called stored procedure, like you know how to write procedures, how to write functions, right? I think you are learning that in your course 1008 sub, right? How to write a small procedure, small function, right? How to pass the parameters, right? So we can have a kind of a small, for example, small procedure. We can write a small procedure like at the appointment procedure. We can give a name called at the appointment, and then we can pass the parameters, doctor's IDs and the patient ID, and the start time of the appointment and the stop time of the appointment. And then we can write a small programming code to check whether there is any overlap between the start time and the stop time. Okay, so we can check the doctor, if the doctor has existing appointment which overlap, and also we can check if the patient has an existing appointment with overlap, right? If there is no overlap, then we can just insert that particular row into other appointment table. Okay, so these are the ways that we can actually implement other specific issues that I have discussed earlier. But we are not going to deal with it in this subject, because this is another ball game, right? A different ball game, a different scenario, different way of handling the databases. So obviously, if you are interested in specializing in databases, so which I am promoting, okay, which I am promoting. Of course, in higher education, we have so I have taught actually a couple of databases there. So there are more complicated database subjects there. I think 4 or 5 subjects you can actually specialize in that, because we are dealing that in those subjects, right? So in this semester, we are not going to write any programming language of we are not going to write programming languages using SQL, right? We just write the SQL stuff. That's it. No programming stuff. Okay. You write the queries, but not programming language. All right. Right. So did you get my point now up to there? Right. So what we need to know is go through the scenario, understand the patterns, and then see whether you have to make a kind of a weak entity or a strong entity in the middle. So and then decide okay, So first we need to actually decide whether it is a strong entity or a weak entity comes into play if there is a many-to-many relationship between two entities. And then think about what is the identifier for the middle entity, whether if do I need to borrow anything or can I live with its own information, you can own columns and make a kind of a unique identifier for that particular entity, etc. So these are the things that you need to think about. Okay, it's not that very straightforward. Sometimes you need to think, right? So what we can learn is patterns. If you know the patterns of these scenarios, you can see all the patterns that we have taught, all the things that we have taught has a kind of a similar patterns, right? Obviously, it's very small minor difference, but the patterns look same. Okay, patterns are look same. Okay. All right, now we are moving into another territory. Now another one we call functional dependency. Why I'm talking this small? This is very small topic, but now why I'm talking this? Because in week 10, not in next week, week 10, I am actually giving you another aspect or another way of designing databases. So obviously you know how to design the databases using entity relationship diagram. So that is a one very popular method of using models to design databases, right? But obviously there are other ways we can use to design databases. So I will teach you in week 10 another way. It's a hard way, I would say. It's a hard way. So in order to learn that, we need to have this thing. Okay. So functional dependency means it's a constraint between two sets of attributes in a relation. Now, if you think about one relation or one entity, you have seen a bunch of attributes, right? But when you take these bunch of attributes or the attributes in a relation, it has a kind of a there's a constraint placed in there by going to you can see the constraint between the attributes. Now, for example, if you think about like this, for example, if I have an entity called R or the relation called R, and then I have three attributes called X, Y, and Z, right? And if I underline Z, X, what do you mean by this underline? Underline means that's a primary key, yeah? So what do you mean by this primary key actually? Primary key means if you know the primary key or the value of the primary key actually determines the value of the other attribute values in the same row, right? For example, if I think like that, if I know your student ID, right, I can determine who you are. What is your first name? What is your last name, right? Your address, your date of birth, right? How many subjects you are taking, etc. Whether you have paid the fees or not. Okay, which countries are you coming from, etc. etc. So all the information I can be determined by going through the primary key of that particular relation. So that means I can say your primary key, that's your student ID, functionally determines the values of the other attributes, values of the name, value of the last name, values of the fees paid, values of the address, values of the date of birth, etc., etc., right? So functional dependency means that, right? So we can actually mathematically show that in like this, and then we can say, okay, X functionally determines the value of Y. Okay, value of Y. So in mathematics, usually we call determinant and dependent. Determinant is the primary key, right? So in this case, X is the determinant, right? Why it is a determinant? Because it determines the values of the other columns for one particular instance. And then the Y and Z's are called the dependence. Why it is dependent? Because the values of these columns are dependent on the values of the X, right? So we can say, so we can write it something like this: X arrow pointing towards Y. So that means X functionally determines the value of Y. Okay. So why I am talking these things? Because the thing is like this, because if you design a database in unknown territory, right? For example, obviously we are talking a Mickey Mouse kind of small scenario. Now think about, you are going to a chemical plant, right? Or engineering plant, or say for example, if you go to the USA and go to NASA and wanted to develop a database there, right? You will come up with the different terms, different jargons, right? Then you need to determine what is actually the primary, what are the entities, what are the primary keys of these entities, what are the dependent, what are the determinant, etc. A whole bunch of issues come into play, right? So now let's take a Mickey Mouse more small example. Now, if you go to a kind of a small situation, like if you go and interview a person and say that company need a small database, and they says, okay, we have something like these names and email addresses, genders, and the birthdays, etc. For example, think about this university, right? So obviously this looks like a kind of, say for example, student or the employee table, right? So we have bunch of attributes. Now we need to apply that functional determinants or functional this dependency dependent kind of relationship and see which one is the best primary key in this scenario, right? So can I take the gender? Now we need to go through one by one and say determine. Can I take the gender as a primary key? Obviously it's not, right? Because we can have more than one female or more than one male in our company, right? So that means gender, uh, male or female or intersex. So we can't take this as a kind of a better primary key because one of the values will not actually determine the values of the other attributes, right? Because obviously we can have multiple instances for the gender, right? Obviously that's not the primary key or the determinant in this scenario. Okay, can I take the birth date as a primary key or birth date as a determinant? Obviously, we can have maximum 365 employees, so 365 unique scenarios. Obviously, we can have more than that, or we can have a birth date having two people having the same birth date. So that means any of the values in the birth date scenario, the column will not functionally determine uniquely the value of the other scenarios or other attributes, right? So obviously, if we can take the birth date as the determinant, and then can I take the name as the primary key? Then of course no, because we can have same employee names twice, right? We can have many multiple John Smith, right? We can have multiple Molly Thompsons. We can have multiple Chanel Pereiras, right? Multiple Shangmin Chais, Kunjal Modis. We can have multiples. We can have multiple Liams. So obviously name is not a basically a good primary key in this scenario, right? How about the email address? Can I take the email address? Obviously, can the email address function? Or if I know the email address, can I see may I know that who is that person belongs to? Who is that person? What is the name of that person? Right? Date of birth? Yes, of course, yes. So because email address usually we are not sharing with others, right? Each person have a single or unique email address, right? So in this scenario, email address can actually take as a base primary key or determinant, which determines the values of the other columns or other attributes, right? So we can say email address determines the value of the name, email address determines the value of gender, email address determines the value of the birth date. Okay. So likewise, we can have sometimes we need to combine many columns as well, because one column itself will not determine the values uniquely on the other columns, right? So that means you need to determine a composite identifier, right? So in this case, we can have, for example, here, if I underline these two, that means A and B in combined functionally determine the values of C and values of D, right? So how can we write that? We can write something like here, right? AB functionally determines value of C, AB functionally determine value of D, right? So the determinant in this case is AB, so that means the composite. C is a dependent and the D is dependent as well, right? Right, so this is a very small topic. It looks like a very trivial topic, but it's very obvious because as I mentioned before, because this is theory. This theory is very important because, as I mentioned, if you go to a unknown problem space, you are dealing with not familiar, unfamiliar terms, words, attributes, etc., etc. There can be many hundreds of attributes. So how can you determine which one is the primary key, which one is a determine dependence? So you can actually apply this what we have done now, right? So in obviously the second method that I am going to introduce, which is called the normalization way of designing databases. In week 10 you will realize this functional determination, this concept is really helpful in that particular case, right? Right. So before actually now, just give me give you a small intro, because there are two ways that we can design. There are two kinds of actually people invented the databases basically, right? So one kind of people is coming from more business background. So they are the one actually invented this entity relationship diagram way of designing databases, because obviously the business rules that we represented in ERDs can be obviously converted into the databases, right? Implemented in the databases. So that is a business perspective of database design. But there are a bunch of people, scientists who are coming from more mathematical side. They are the one who implemented these or discovered the second way of designing databases, which we called it as normalization way, which I have actually discussed now, because there is kind of mathematics involved, a small bit of, right? So dependent, determinant, right? Which how to determine determinants. So these are coming from the people from the mathematics background, right? So in my experience, I have realized, even me when I'm studying, I struggle a lot to understand the normalization way, the second method of designing database, because it's really hard sometimes. But the ERD way, it's obvious. It's very easy. If you know the patterns, if you know the business rules, and if you know this basic theoretical parts, how to determine the entity, how to determine the relationship, how to determine the primary key, when do we need to borrow it, do we need to can we implement in using the same scenario information, etc. So if you know the small bit, you can easily design ERDs and design the database. So therefore what I decided is to teach ERDs first, because it's obviously easiest way to design databases rather than normalization way. So that is why I just deferred it until week 10 to teach you, because sometimes when I teach, if I taught you that in the first 4 weeks, you will say, okay, bye bye to database, and I will leave, because it's little sometimes bit confusing. I don't want people students to make. I mean, I obviously felt the same way when I learned all these things when my teachers in Swinburne, actually, I'm a product of Swinburne as well. When they taught normalization, I felt, oh my gosh, I don't want that. Okay, so yeah, so that I thought that I will teach the other way. So anyway, are you enjoying this subject, by the way, guys? Can you just I just wanted to know your feedback. Are you enjoying this subject? So is it a fun subject or what? Can you just give me your thoughts? Just yes or no. That's I wanted to know. Are you actually enjoying this subject? How about just give me Molly, Kunjal, Liam. Are you? It's bit content heavy and hard to keep that up with, but it's not that bad subject. Yes, thanks. Molly, others. Kunjal, like is subs. Liam, yeah, absolutely. Yeah, thank you. How about Shena? Mukesh here. Are you enjoy? I actually I want everybody to enjoy this. This practical, isn't it? It's practical stuff. Yeah, okay. Better than the last time I did the database. Okay, thank you. Okay. Hope that I achieve my target way of okay, good. Chanel, I was fun until last week. Now it's getting bit hard. Don't worry, I make it. Man. So don't worry. So when you go through it, actually it's actually nothing much. just try to listen to my lecture again. I'll give you another help, right? So let me know. I want you guys to rather than I'm giving every bit and pieces, just think about a little bit, because that's the way of learning, right? So it's not like, you listen to the lecture and then the next week when you feel like, oh, I'm uncomfortable with certain concept, can you re-explain this? I'll re-explain it again. Okay, so then of course that's how we learn. All right, now let's move into yeah, this is another thing that I actually like to mention. This very small bit, a small thing. Sometimes I also felt a little confused when I work in the industry. Obviously, it's actually nothing to worry, but I thought I should give you this thing, so I have included that in as a part of the lecture. Right now, think about this scenario. Sorry, just go back. Oops. Think about this scenario. Imagine that the Swinburne, we have meetings, right? Sorry, we have meetings. No, every year we have different types of meetings. So staff are invited for different meetings, right? So we have staff entity, we have a meeting entity. Say for example, we have meeting like to discuss how we going to go with December Christmas party. Okay, so so staff is a strong entity. Staff IDs is the identifier, and then we have the staff name, and then we have the meeting entity. They have given the meeting ID actually. So meeting ID is the identifier, and then they have given also the meeting date and the meeting time in this case. Right now, here the meeting is a separate entity, right? So what they want is uh, now the staff are invited to multiple meetings, and one meeting can have many staff. So obviously we have many to many relationship between here. So what they want is they want to actually record the attendance, right? Record the attendance, and also they wanted to actually record who is the minute taker of the particular meeting, right? A minute taker means the person who actually records the important actions and decisions made during the meeting. So how can you make, how do you obviously record these two things in an ERD diagram? So that is my next question is. So imagine now we have created this small ERD. Now obviously we have many-to-many relationship here. So we can't live with that, isn't it? So that means many-to-many means definitely we need to create some entity in the middle, right? So we need to expand this, in other words, right? So when I expanded it, I can have a weak entity called invitation, right? So staff are invited to meeting. That is what we mean by the invitation, right? And then we have an attribute called attendance. So I can mark the attendance when they attended the meeting, right? So what is the identifier for the invitation? So identifier for the invitation is I need to take the staff ID and the meeting ID as well. So we have three attributes in the invitation: entity, staff ID, meeting ID, and the attended column. Now attended column I write Y for attended, N for no, right? Not attended, right? Right. So what I can do is when we send the invitation to the staff, okay, can you? So I need not to send all the invitation to all the staff, certain staff only, right? If I send the invitation to the certain staff, so I need to include, I need to actually have rows inserted into the invitation column, right? So what I can do actually is I can insert to the invitation column, I can make this attended column by default to n, right? By default to n, right? For example, if I send 100 invitation for the 100 staff members, so I can have 100 insert statement. Each insert statement has obviously said attended by default n. So why I put as a default as n rather than, usually we keep it as a null, right? Remember the null, okay? Because there are so many problems if I have null in this case. So we'll see what will going to happen if I put null, right? if somebody is not attended to a particular meeting, do I need to do anything? Do I need to do anything if someone is not attended for any meeting or that particular meeting? I don't need to do anything, right? Because by default, since I place as attended as null, so no or n, so that means I don't need to do anything for that particular person, that particular row, right? But if a person attended that meeting, what I can do is I can run an update statement, right? I can update that particular row, right? So I can replace n with y. Okay, so I can run update invitation set attended y, where this meeting uh, for the staff member for this meeting ID, right? So that is what I can do. Actually, in practice, we don't need to run now. For example, if there are 100 or 50 staff members attended, I need not to run up 50 update statements. So in practice, we usually design a form, right? We design a form. So background of the form, we have this update statement. So each time when I click and drag, click and select the specific staff member, specific meeting, specific date, etc., and press click. What will happen is this update statement automatically created by itself, right? And it replaces this value and update the invitation. So that is how it works in practice, right? But how to design it, so as a designers we know what is the background. This is the background process, right? This is the background process. So we need to know how the background process is working, because we are the one who is designing this. So the users don't know this is going to happen, right? They just click and click and click, press OK, then obviously it populated, then goes to the invitation, update the invitation entity, right? Right. So, but this is something that we need to know, right? So we can only update people who attended, right? Sorry, what is this one? So if they don't attend, I don't need to do anything, yeah. So I didn't put null values as a default value, because remember, if I place the null values initially, then obviously I have more issues, because then what are the issues if I place the null values here? If I place the null values here, the one problem is each time if the person is not attended, I need to update the non-attendance. If they attended, I need to update the attendance, right? So there's a double work for me, isn't it? So therefore, in this case, it's much better we put the default as n, right? Not attended, right? So I don't need to actually update two things, right? And the other thing is, other problem is if I have nulls, if I trying to run a query, remember null values ignored by some of the queries, right? So it's more work for us. It's more work for us to create some reports. For example, if my manager asks, okay, Ravinder, can you please give me a report who has attended and who has not attended? Um, um, and then I can simply run this kind of a statement, okay, with the unions to select statement. This is the attended people. These are not attended people. So very easy, right? But if I use null, if the null values will not going to display or show it in our report. Otherwise, I need to have another select statement to see whether the display the not null values, right? So it's too much of work for us, right? So you don't need to do that in this sort of situation. So you need to think about, right? And then okay, then these small bits and pieces. For example, if I get a question from my manager saying, how do you indicate that the person wasn't invited? How do we know that actually person wasn't invited to a particular meeting, right? So that's very easy, because if a person don't invited, so I don't want to actually add any row to the invitation, right? So I I insert the invitation rows or invitation caller or invitation table only the people we have invited, right? So we don't put anyone who is not invited, right? So that is something that we need to understand, right? Right. So now let's say now they have given some test data. For example, they have 3 employees, Fred, Sue, and Dave, and then there are 3 meeting dates or meetings that they have going to held: 1st of June, 3rd of June, and 4th of August. And then this is the attendance entity, so it actually indicates who has attended, who has not attended, right? So for example, if they ask a question like, was the Dave invited to meeting number 1? So the Dave meeting number 1, do we have that combination ST03 and M1 here? ST03 and M1 is not there, right? So not there. How do we know that it's not, he is not invited? How can you make sure? How can you, for example, if this meeting entity say, for example, if I have 1,000 rows, how can you know that Dave has not invited? So how do we know that? What we can do is I can actually run a simple aggregate function like count function, right? I can use the count function to see whether we have more than 1 row, how more than one in combination of ST03 and M1, right? If we have more than one, that means it, or if we have one, actually not more than one, if we have one, so that means we have invited the Dave into that particular meeting, right? Then the next question is how many meetings that the Sue has been invited. Sue, that means how many times ST02 appears in the meeting. That is what they wanted to know, right? So what I can do is I can actually simply run another aggregate function, right? So select count, etc., etc., say whether where uh, std or staff id is equal to st02. That's what I need to do, right? So just a simple count function, so it will give how many times the Sue appears in the invitation table, right? That is how we do that. Then did the Fred attended the meeting number 3? Fred attended the meeting number 3. Then what we can do is we can check whether this combination is yes or no. Okay. So likewise, these are the small things. So sometimes we need to know whether we need to aggregate function to determine it, or we can simply use where clause, etc., etc. So something that you need to think about. Okay. So same problem, and then the other thing, actually I have forgot to mention there. Just take the snapshot to explain that. Let me actually take the snapshot. The second issue is, now the first issue is the attendance issue. I think I already explained the attendance issue. So the second issue is how do we know that who is the minute taker for a particular meeting? How do we know that? How do you report that minute take information here? Any particular anything that you like to add? How do we know that minute take? So what we can do is, if I wanted to know who is the minute taker for a particular meeting, so I can actually, without adding any attribute here, right? So sometimes people may think, okay, why don't we add an attribute like, okay, minute taker or something like this, right? So you can do that, but obviously without doing that, what we can do is we can have another relationship between this and here, right? One to many. We put the this ID here as the foreign key. So what do you mean by that? Is each row in the meeting, right? Each row in the meeting, we have a staff ID associated with it as a foreign key, right? So that staff ID is the minute taker for that particular meeting, right? That particular meeting. So we can actually simply do that rather than creating another column here. If you create the column, it's sometimes a bit complicated, right? So we can actually obviously, without going through that path, we can simply add the foreign key to this entity to have that minute take information there. So obviously, yeah. So that is that is how we solve that problem. Okay. So that's very small fix. Small fix. All right. So that is something actually I like to emphasize you, because it's very important. When you go to the industry, you will actually come up with this small, very small minor thing that sometimes it's very too many thinking things. There are too many things to sometimes you make very complicated. You may think it's a very complicated issue, but actually at the end of the day, it's a very small issue, right? Right. So the same actually thing applies to the other scenarios and students who are enrolled in the subjects. Right. Now remember the student enrollment issue that we have discussed last week, because subject, we have subject offerings, right? Offering entity. Remember the offering entity that we have discussed last week. So each subject have many subject offerings, and the students are enrolled in the subject offerings, right? Not the subject, right? They enrolled in the subject offerings, right? So how do we know the particular student is enrolled in the subject offering? Then we can actually count whether that particular combination of student and the subject offering, how many times it has been occurred in the enrollment, right? So the same principle applies as earlier. If the student is not enrolled in a specific subject offering, we don't need to actually insert a row into the enrollment entity, right? So only insert a row to enrollment if that particular student has enrolled in. So same like here, right? Only insert a row into the invitation if the staff are invited to particular meeting. Otherwise, don't insert a row into the invitation. So same principle. Okay, right. Something that I actually like to emphasize these things. Okay. Now we are actually recapping what we have learned in ERDs. I think I have went through this last time as well, or the last time, I can't remember. But anyway, now remember, when you design the entity relationship diagram, you may actually come across different types of relationship, or sometimes we call degrees of the relationship between the different types of entities, right? So we can have a relationship called a unary relationship, right? So we have one entity, but the instances of the entity have a relationship between each other. So that is what we mean by the unary relationship. Or we can have a binary relationship. That means there is a relationship between the two types of entities, right? Or even we can have a ternary relationship. That is what I'm going to talk now, right? Ternary means three, relationship between three entities, right? So the most relationship, when we go to the industry as well, we will see the most relationships are the binary type of relationship between the two entities. Students are enrolled in the subjects, right? Staff are invited to the meetings, right? Etc. etc. So binary relationships are very popular relationship in any database models. But still, we can have ternaries. We can have actually more than ternaries sometimes. So if you have more than three entities, it's referred to as an array relationship, right? Or we can have 5 arrays, or 4 arrays, or 10 arrays. I haven't actually put more than 3, but there can be situations, right? So that's something that you need to remember. But we are not going to touch that. So the only thing we need to touch is these 3 things, right? In our this semester. Right, so some example for the unary. So unary means entities of the same type are related to each other. So say instances actually in the same type of entity related to each other. The classic example is employees. So some employees are managed, some other employees. So what do you mean by that? That means some employees are managers. They are managing some other employees, right? So that means the relationship actually lurking around the same entity, right? So that is what we mean by the unary relationship. So the binaries are is very popular, right? one employee can work in a one department, or one department can have many employees, one employee can have work in a one department, etc., etc. So department and the employees have a binary relationship, but we have the ternary relationships, right? Once we can have kind of saying one product can be one product, or one supplier can actually ship many products to many warehouses or particular warehouse, right? So warehouse, product, and the supplier have a ternary relationship in this case, right? So three type of entities involved in that relationship. Now this is a little bit interesting thing, because we need to learn this now, right? So this is what we are going to learn now in our. Okay, I'll do two case studies. So the first case study, now let's go through a first case study regarding the ternary relationship. I'll do another example actually next week. I'll do a kind of very big, huge case study. So next Friday, sorry, next Wednesday lecture is dedicated for one case study. I'll go through one ERD diagram or one scenario, and I will recreate the ERD, and I'll show how you're going to actually deal with the big scenarios. Okay, so I need to actually demonstrate it for you. So next Wednesday lecture entirely for one scenario. Right, now let's go through this one. Now think about this scenario. Right now they have given this narrative for us. Now let's read this narrative and try to understand this. Now it says a school. Now this is a school, right? Typical school. Its school has a number of music students. So we have different students. So for example, we have Sue, Roger, Ted, Wendy, maybe Molly or Liam, okay, Chanel, etc., etc. And then a school teaches students to play a musical instrument. So there are so many musical instruments in the school: pianos, violins, drums, bass, guitars, etc., etc. And then a school has many musical groups, right? Musical groups, right? So they have many musical groups. They have even some names for the musical groups, like rock band 1, rock band 2, choir 1, choir 2, folk 1, etc., etc. And then they have given some bunch of business rules. Okay, bunch of business rules. Now let's go through the business rules now. Now these are the very important, right? So any database design, business rules are very vital, right? Because we need to implement that in our database design, right? Very vital, very important. So let's go through these business rules. So first business rule says a group can have many music students, all right? So more than one student can have in a group. A music student may play in more than one group. So if you think about one student, that student can play in more than one group. So that is obvious. So there is no restriction for students to play in more than one. Right? That's what it says. Then the third business rule, it says a music student may play many instruments, right? So they can play many instruments, right? So I can play drums or piano or violin, etc. And then they consider the vocals as an instrument as well, right? So if a person can sing very well, that's kind of instrument, okay, vocals. And then a group may have many instruments. So group can possess many instruments as well. There is no restriction. They can have 2 guitar players or 2 violin players, etc., etc. An instrument may be used in many groups, right? An instrument may be used in many groups means one instrument can be shared by many groups as well, okay? And then the next one, a group may have more than one musician with the same instrument. That's what I have said before, right? So we can have 2 drummers, 2 piano players, 2 violin players, etc., etc. And then the last one, the last business rule is very important business rule, because the principal in this school won't strictly adhere to that business rule. What it says is a music student may play only one instrument in any single group, any given group. One music student can play only one instrument, right? Because why the principal has implemented that, probably he or she doesn't want a person dominate the whole group, right? Because sometimes if I have multitasking, skills, principal don't want that person dominate the whole group, right? So to give the others a chance, they says, okay, one student can play only one instrument in a one single group, right? One single group. Okay. Right now, the principal asking us, okay, can you please give me a list of musicians uses which instrument? You want to have a list of musicians in which instrument they are playing in which group, right? Which instrument they are playing in which group, right? That is the report they are asking us to produce, right? Now, the first thing first, so what we need to do here in this case, first we need to now design the interrelationship diagram. So to design the interrelationship diagram, we need to now go through and understand what entities are involved in this ERD, right? That is the first thing, right? Right, basic. Now let me make it very simple. So let's assume that um, we don't have much attributes, so let's take only the primary key of each entity and try to understand the scenario. Now let's take, now how many actually entities involved in this. So they are talking about the students, so definitely students is entity. They're talking about instrument in here, so instrument basically another entity, isn't it, or another object I need to represent. And then they are talking about musical groups, then that might be another entity in our database, right? So obviously uh, there are maybe three entities, right? Three entities looks like a ternary, right? Ternary, three entities. So let's take first one. So they have given some sample there. It says the David is a guitarist in the rock band one group, Sally is a vocalist in the jazz one group, Sally is also a pianist in the rock band one group, etc., etc. So they given kind of some sort of some information, sample data. So let's now build our ERD. So first I will build first relationship. Okay, so it says the music student can play or can learns to play many instruments. So one music student can learn to play many instruments, and then one instrument can be used by or learned by many music students, right? So we have two entities, many-to-many relationship between these two entities, so music student and the instrument. For the simplicity purpose, I just take only one attribute. I take music student name as an identifier, right? So name of the person as the identifier. So I make an assumption there's no two names repeating for the simplicity purpose, okay? And then I'll take the instrument name as a primary key as well for the simplicity purpose, right? So there is obviously many-to-many relationship between the student and the instrument, many-to-many, okay? So that is the first relationship. The second relationship. The second relationship is between the music student and the group, right? If you go through the scenario, it says one music student can play in multiple groups, right? Many groups. So there is no restrictions, and also one group can consist of many music students. There is no restriction as well. So obviously there is a many-to-many relationship between the music or the student and the group. So the group in this case another entity. So I just take the group name as a primary key because there is no two groups have the same name, right? So there is a many-to-many relationship between the student and the group as well. And then the third relationship is between the groups and the instrument, right? It says an instrument can be shared by many groups, right? Or played in many groups, right? There's no restriction. And then also one group can be having many instruments, right? They can use many instruments. There's no restriction how many instruments they can have. They can have many. So obviously there is a many-to-many relationship between the group and the instrument as well, okay? Right, so that means at the end, once I put everything together, I can have this model, right? So there's a many-to-many relationship between these three entities. So we can have actually three binary relationship, right? Three binary relationship. Binary means between two entities, right? So one, two, and here three, right? Three binary relationship. Right, so we have the identifiers in each entity, right? So that means now if I have many-to-many relationship, obviously I need to expand it, right? I need to expand it. So what I can do here is to create the weak entities in each of these many the middle of each of these entity into many relationship, right? So I have three weak entities now, right? Three weak entities now here. In this case, I just combine actually the two entity names to make to give a name for the weak entity. So just combine the student and the instrument. I say student instrument tuition, right? And then here I say student group enrollment. So which student enrolled in which group. So that's what it shows in this weak entity. Here group instrument requirement. So which group obtain or have which instruments, right? So that's information recorded here. And then I need to actually determine what are the primary keys of each of these weak entities. So what is the primary key of the student instrument tuition? So I need to grab the primary key of the both ends and make a composite identifier here. So here in this case, student name and the musical instrument name comes here as a primary key. And here group enrollment, I take the student name and the group name, right? So as a primary key. So here the third one, I take the group name and the instrument name as a instrument requirement. Okay. So looks like it's a first glance when you have a look, this one looks like it's a reasonable solution for the what is the problem that we have now. They have wanted to actually produce a report saying which person playing which instrument in which group, right? That is the report the principal asking us to produce. Yeah. So looks like now we have expanded, looks like it's obviously we can produce it. Now let's see whether we can produce the report, right? Right, so now let me put some test data to each of these weak entities, right? Now first week, now these are the test data, colored band music, band, I think this one, yeah. Band and musician name. So band and music. So this is this one test data here, and then the second one is band and the instrument. Band and the instrument is this. So this is the test data in the green color, and then the third one, the instrument in the music. This one is there right here. So these three entities, three weak entities, right? Now let's go through this, and can we now determine from these three weak entities, can you determine, I'll ask a question, can you determine who does what in each band and what instrument? For example, what instrument Sue plays in the rock band and what instrument does the Ted plays in the rock band? Can we determine this information here? Or does it enforce the rule a student? Okay, so let's forget about the last one. Let's think about the first two. Can the Sue, which instrument the Sue plays in the rock band? Now, if you go through the here, the first table, it's actually giving you information regarding the band and the musician in the band. So the rock band, if you think about the rock band, you can see the Sue is in the rock band, yeah. So Sue is in the rock band. And then so the question is asking what instrument the Sue plays in the rock band. So Sue is in the rock band, and then the rock band is having three types of instruments, right? Vocals, guitar, and the drums, right? And then this gives, the third one gives which instrument each musician is playing. Now Sue here, you can see here she is playing vocal, she can play vocals, she can play pianos, she can play drums, right? So she can actually play three types of instrument, right? But if you think about the rock band contains three types of instrument. But which instrument that she is playing in this rock band, it's not so clear, isn't it? Because it says Sue is in the rock band. Yes, we know that. And rock band contains this instrument. And Sue also can play these instruments. So which instrument she is playing in the rock band? So same applies to the the Ted, right? Ted also in the rock band, right? Ted also in the rock band, and Ted can play drums. He can actually sing. He can play the guitar, etc., etc. So which instrument is Ted is playing here, right? So can we determine that in this model? Because now we have expanded it. Obviously, these are, so we have to weak entity. So it's not that easy, right? So this model actually will not going to give you any information regarding which instrument paid by which student at which band, right? That information actually obviously not obviously can be determined by this model. So what we can do is now, since we can't determine this, we need to come up with a solution. So what is the solution is, if I actually closely monitor these things, right now this is 3 weak entities. So if I can create a super duper weak entity in the middle, so we can actually obviously can have that information. For example, here I have created a super weak entity. In the middle, I call it as student group instrument allocation, right? Student group instrument allocation. So what I have done here is a combination, combining these 3 weak entities, and not the strong entities, 3 weak entities. 3 weak entities. Now this is a ternary relationship, right? This is a ternary relationship. So if I create these 3, yeah, your brain is no, that's Mori, don't worry. This is a, this is very easy. No, don't worry. Now let's jump to the next one. I'll show you this, how easy is this. So once you create this weak entity, once you create this weak entity, now what this weak entity means, how this weak entity means, so we need to include this weak entity shows you which student, which group, which instrument they are playing. So that means if I take the primary keys of each of these entity and combine it, I can get that information over there, right? Okay. So let me go to the next slide. So that weak entity contains a student name, instrument name, and the group name, right? So Ted, guitarist, can play guitarist in the rock band 1. Roger is a guitarist at rock band 1. So you can see, so now, so if I take these 3 as a primary key for that weak entity, it looks reasonable solution, because each is unique, right? So Ted, guitarist, rock band 1, Roger, guitarist, rock band 1. Sue is a vocalist. Can she is playing vocal in the folk 1, and Wendy is a pianist in the jazz group. So it looks like okay. So it says, actually shows which person now playing in which instrument, in which group in this middle entity. So then the next question is, what is the primary key of this entity, right? What is the primary key? Can I take, now this is actually a foreign keys, yeah, if I take the foreign key. So what is the primary key of this entity? So if I take student name, instrument name, group name, all 3 in combine as a primary key, does it make sense? Does it actually work? And this work in the, does it actually acceptable? That's my question is, right? So I just give a name for this super weak entity as an allocation, right? Student name, instrument name, group name. So I just, if I underline all 3 as a composite identifier, so that does it make sense? Now, for example, if I go through this model or this sample data, Ted is a guitarist in the rock band 1, is a unique key. Yes, it looks okay. Roger is a guitarist in the rock band 1, yeah, it's unique. Yes, so look okay. And Roger is a vocalist in the rock band 1, it's a unique, it's okay. But there is a problem. Problem is, now technically it's correct. Technically it's correct. But the problem is, we violate what? We violate most important business rule. What is the business rule? Now remember the business rule set up by the principal. He or she doesn't want to anyone to dominate any musical group, right? It says a person can only play one instrument in each of the band, right? So in this case, we cannot enforce that business rule if I take all three columns as the primary keys. Indeed, student name, instrument name, group name is actually, it's obviously okay as in terms of the technicality, it's okay, right? Because it's a unique primary key. So it's actually not. So how are you going to overcome that? How can I actually choose a primary key which best suits to this particular business, this particular business rule? So what I can do is actually small thing, right? Small thing I need to do. So what I can do is, rather than taking all three columns as a composite identifier. So there are so many ways that I can actually implement it. I can actually implement it using non-ERDs, as I mentioned before. I can use programming code to implement it and see whether is there any breaches in the primary key in this combination. I can do that. I can create a unique constraint if I want. Remember the unique constraint, and so I can create a unique constraint in my allocation. This is allocate super weak entity. I can put a constraint saying these three combination will not going to work, right? Or I can create an index. So I'll actually teach you this one maybe later on, how to create the index, which will not going to allow the duplicate values for any given table, or sorry, any given column. So there are three ways actually we can implement that business rule. But rather than actually going through this path, can we find a better business rule from the ERD means, or ERD, using the ERDs, right? By going through the ERD to reflect. So actually what we can do is, we can just have what I do here is to simplify the model. Now this is the model we have, right? So we have three entities. Music, student, group, and then now if you have actually the ternary relationship. Now remember, in the binary relationship we take only now when you read the relationship between these instances, so we start with the one, right? One employee belongs to many groups, right, or many departments. So one department can have many employees, right? Something like that, right? We start with one with one single entity, right? One employee belongs to one department. One department may have many employees, so always one with a single entity. But when it comes to the ternary relationship, we need to actually take one single instances, but with the two entities in this time, right? For example, you can say one music student and one group, right? One music student and one music student and one instrument. One music student and one instrument, right? May have many groups. So one music student can play one instrument in many musical groups, right? So one, many, okay? And then one group and one student, one group, one instrument, right? One group, one instrument can be played by many music students. One group, one instrument can be played by many instruments, right? And then the third relationship, one music student in a one group actually can play only one instrument, right? One music student, one group can play only one music student, one instrument in a one group. So that is the business rule we need to capture, isn't it? One music student in a one group can play only one instrument, right? But the other relationship all many, right? So group instrument many, music instrument, student instrument many, but this combination is the only one. Okay, so so that means one music student, one group, one instrument. So that means if I actually underline the student name and the group name, that's actually enough for a primary key, right? Because one music student, one group in combine, right? One in can combine can play only one instrument in a group, right? So one student, one group cannot be repeat many times in this case, right? In the allocation table, that is what we mean by that, right? In the allocation table. So I need not to actually underline all three columns. Instead of that, I can actually underline only student name and the group name only, right? You understand that? So that's how we solve that matter, because it's a little thinking, because otherwise obviously we just simply underline all three and say, so, okay, that's a perfect. I say perfect identifier, yes, I understand that, but it actually will not going to implement the most important business rules. So in that case, we need to actually go through the model again, simplified model, to think about that pattern and then implement it. So because in here it's very easy, because we can straightforwardly implement, where some cases we need to programmatically implement it, or in other ways, using unique constraint way or something other ways, right? But in this case, we can easily implement it, right? So that is something that you need to think about. So that means now if I come back to our final model, now this is the model, the weak entity here, the super weak entity in this here. So we just underline this side only, because this is where we are taking the group name, because this weak entity contains what is the identifier or the primary key for the student group enrollment entity. So group name and the music student name, right? So we take only this as a primary key, right? So music student name and the group name, right? Right. So so you just underline only this part, right? So don't underline the other relationship. That's what I wanted to tell you. Okay. Same applies for the second case study. Now this case study is another one, but I just giving you differently. Here we have a scenario. We having vendors, right? So they are supplying parts to the warehouses. So we have many vendors supplying many parts to the many warehouses. So we have a business, right? We have a business, different warehouses. There are so many vendors or suppliers. They are supplying parts for different warehouses, right? So so what we have is this model. So we have three entities. There is a relationship between these three entities, with many to many, many to many relationship. So same principle. So we have three entities, window, parts, and the warehouses. So we have many to many, many to many, many to many relationships. So I just showing you in a different ways rather than connecting here, right? And then so each part supplied by the vendor have a different ways of shipping, right? So shipping, we call it as shipping mode, and each part has a different cost unit or unit cost or supplying cost. So shipping mode and the unit cost actually need to become here in the middle, or the super weak entity that we create, like here. Okay. So if I create that super weak entity in the middle, now it looks like this. So in this case, I name it as a supply schedule, that weak entity. Now remember, we need to put actually double line here, but this is single line, but double line, okay, because they are using a different symbol. Just make sure you put the double line. So in this case, we have that weak entity two attributes by itself: shipping mode and the unique cost. Um, and then yeah, so and then what we can do is we can determine the primary key of this. Now in this case, there is no such business rule saying each vendor supplies certain part to the certain warehouses. So therefore in this case, we can take the vendor name, part name, and the warehouse as a primary key for the supply schedule or the super weak entity in the middle, right? So this is a very straightforward. Just have a look, just read this, then you will understand this. And then if you actually go to this, there's some notes as well, so you can see that it popping up. So I just have explained that as well. Just have a read it, okay? Right. So this is a second case study. Right. So I'll do the third one, the bigger case study with the Turner relationship probably next week. So you will realize if I actually put all what we have learned so far into one big case study, it looks like very complicated, right? Because we learn a lot in ERDs, right? Right. Now we are coming to another. I think another. This is a very small part. Cascade constraints. Now remember, when trying to create the tables, you first create the main entities first, right? Main entities first, and then you create the weak entities second, right? Strong entities first, weak entities second. So, other words, we create the parents first, kids second, right? So, if I want to delete something or delete parent, first we need to delete the kids, right? We need to delete the or kill the kids and before killing the parents. So that is the rule. Remember that rule, right? So sometimes now, for example, if I have a database with hundreds of tables, say 100 or 200 tables, it's very difficult as to remember who is parent, who is kid, right? If I want to get rid of some tables, so it's not an easy or straightforward way to understand who is parent, who is child, right? Child entity. So what we can do is we can use this cascade constraint statement to delete any table as we wish, right? For example, now here, what I'm doing here, I try to find out what are the tables we have in our database. So I just simply access the data, what do you call data dictionary, right? Remember the data dictionary table, select table underscore name from tabs. So you will get all the list of tables that you have created, and then we can drop any table we wish by using cascade constraint statement in there, right? So drop table, movie, cascade constraint. Now what it says is ignore parent-child relationship, right? So that's something you can actually, but I'm not actually um, I don't want you to use this one because you need to know which table comes first, which table comes second, right? But in practice, when you go to the industry, obviously you need to use this to drop the tables and recreate some tables because of that problem, because of parent-child relation, because you can't keep remembering everything. Okay, something to think about. Right, so next week, this is the case study I am doing. So the case study is called EdTech. Case study is it's a small educational institution. So I just go through it and I will show you how we are going to create ERD. I mean, we need to go from the scratch. How to start, where to start, what to think first, right? So which steps comes first, right? For example, I'll go through it and I will show you how to do it. Okay, so so it's already on the narrative. I think I'll update it on the canvas probably this week, right? On your canvas site. Right, so that's about the lecture, guys. So if you do you have any questions?